Good evening, and welcome to tonight's episode of Science to Sleep By. Tonight, we take a journey beyond the stars, into the farthest reaches of imagination and discovery. As you rest, let the sound of my voice carry you across the galaxies, into the mysteries of time and space. This is not a lecture, but a voyage, a soothing exploration of one of the greatest questions humanity has ever asked: what lies on the other side of the universe? As you breathe deeply and let your mind relax, allow curiosity to gently mingle with calmness, and together, let's drift into the cosmos. When we look up at the night sky, scattered with countless stars, shimmering planets, and the faint glow of distant galaxies, it is natural to wonder what lies beyond. The universe stretches in every direction, expanding farther than the human mind can comfortably imagine. Yet even with all our telescopes, satellites, and instruments, the question of what exists on the other side of the universe remains as mysterious as it has ever been. This keynote is about embracing that mystery, about understanding why the concept of an other side is both profoundly scientific and deeply philosophical. For thousands of years, human beings have turned their eyes to the heavens and asked the same question: is there a boundary, a wall, an edge where everything simply stops, or is space infinite, eternal, and unending? The night sky gives the illusion of permanence, a painted dome of twinkling lights hovering above us, but science has shown us that what we see is only a fragment of a much greater reality. Each point of light in the sky is not merely a star, but in many cases, entire galaxies filled with billions of suns. Behind those galaxies are more galaxies still, stacked layer upon layer, stretching out in every direction. What is remarkable is that no matter how far we peer, no matter how powerful our instruments become, we keep finding more. The James Webb Space Telescope, one of the most advanced windows into space humanity has ever built, has revealed galaxies so ancient and distant that they existed less than a few 100 million years after the birth of the cosmos itself. These discoveries remind us that the deeper we look, the further the unknown stretches. The other side of the universe, if such a thing exists, is hidden far beyond even these unfathomable distances. To even consider what lies beyond the visible stars, we first must understand that what we see with our eyes is limited. Light travels at a finite speed, and while it is incredibly fast, about 186,000 miles per second, it still takes time to cross the universe. When you look at a star, you are seeing it not as it is now, but as it was when its light first left on its journey toward Earth. Some of the stars visible tonight may have already died, their light still traveling across the vast emptiness of space, arriving to your eyes centuries or even millennia after their true end. In this sense, the night sky is not a window to the present, but a time machine, offering glimpses into a universe that once was. And yet, even with this cosmic time machine, we can only peer so far. Beyond that, there may be an endless continuation, or something entirely different, concealed from our senses. When we speak of the other side of the universe, we brush against the limits of language. The phrase suggests that the universe has edges, like a map with borders or a room with walls. But in truth, space does not behave that way. The cosmos may not have an edge in the sense we usually imagine. If you walk to the end of a room, you can touch the wall and know it has boundaries. But the universe might be curved back on itself. Like the surface of a sphere, where traveling in one direction forever could eventually bring you back to where you began, without ever encountering a literal end. Or it may be infinite, stretching endlessly in all directions, with no boundary to reach at all. To ask what is on the other side of infinity may be like asking what is north of the North Pole, a question that challenges the very framework in which it is asked. Still, the allure of the unknown continues to call us. Throughout human history, when people reached the edge of their maps, they wondered what was beyond. Early sailors imagined dragons and sea monsters lurking past the horizon. Explorers spoke of lands shrouded in mist, waiting to be discovered. The stars themselves were once thought to be distant fires fixed to a celestial dome. Now, in the modern age, our maps of the Earth are complete, Yet our maps of the universe are only just beginning to take shape. Instead of oceans and continents, our unknown is measured in light years, in billions of galaxies, in cosmic structures so immense that they defy imagination. And beyond even those, there is more still, hidden, veiled, waiting to be explored. The great unknown beyond the stars is not only a scientific question, but also a deeply human one. For many people, gazing into the heavens awakens a sense of awe and humility. In a world filled with noise, distractions, and the weight of daily life, the stars remind us of something larger, something eternal. They whisper of mysteries far greater than ourselves, and in their silent glow, we are invited to wonder, what lies beyond? Is there an end? Could there be other universes, or realms we cannot comprehend? Or is the truth so vast that it will forever remain beyond our reach? These are not questions with easy answers, and perhaps that is why they are so powerful. To contemplate what lies on the other side of the universe is also to confront our own limitations. The tools we build, the telescopes, the detectors, the observatories, are extraordinary, but they are still small in comparison to the enormity of the cosmos. Every discovery we make only pushes the boundary of the unknown further outward. Like a flashlight beam shining into darkness, we illuminate what is near, but the shadows continue beyond. Yet even in this limitation, there is beauty. The mystery itself becomes a source of wonder, a reminder that the universe is not a puzzle to be solved in a single lifetime, but an endless story unfolding, chapter by chapter, across the eons. The stars, the galaxies, and the void between them are not silent in the way we might think. They tell us their story through light, through faint signals that travel across unimaginable distances. Radio waves, cosmic rays, the faint afterglow of the Big Bang, all these are whispers from the cosmos, clues about what lies beyond. Scientists listen to these whispers, piecing together the story of the universe like archaeologists unearthing fragments of an ancient civilization. Yet even as we learn, the great unknown remains, just out of reach, a horizon always receding as we move toward it. The other side of the universe, then, is not just a place. It is an idea. It is a mirror reflecting our own curiosity, our desire to know, to explore, to understand. It is the ultimate frontier, not bound by geography, but by the very nature of existence. To think of it is to stretch the imagination beyond comfort, into a realm where words begin to falter and concepts dissolve into mystery. The great unknown beyond the stars reminds us that no matter how much we discover, the universe will always hold more secrets than answers, more questions than conclusions, more wonder than certainty. When we imagine the universe, it is tempting to picture it as a vast but static stage, a silent backdrop against which the drama of stars, galaxies, and planets unfolds. Yet science has revealed a truth that is far more extraordinary and far more mysterious. The universe is not fixed. It is not stationary. It is expanding. Every galaxy, every cluster of stars, every luminous island in the cosmic sea is drifting away from us, carried by the fabric of space itself stretching outward. To think of the universe as expanding is to recognize that the cosmos is not only a place, but an event, an unfolding story, a grand dynamic process that has been in motion for nearly 14 billion years. To contemplate what lies on the other side of the universe, we must first understand that this other side is not still, but ever shifting, constantly receding farther and farther from our grasp. This discovery was not always known to us. For much of human history, people believed that the universe was eternal and unchanging. The stars were thought to be fixed in their places, shining down from a perfect and unaltered heaven. It was not until the early 20th century that astronomers, peering deeper into space, began to notice something remarkable. Edwin Hubble, observing distant galaxies through the powerful telescopes at Mount Wilson Observatory, found that their light was redshifted. This redshift meant that the wavelengths of light were stretched as the galaxies moved away, like the lowering pitch of a siren as an ambulance drives past. What Hubble had discovered was revolutionary. The farther away a galaxy was, the faster It was receding. This was the first evidence that the universe was expanding. The implications were profound. If the universe is expanding today, then in the past, it must have been smaller, denser, and hotter. Follow this logic backward far enough, and you arrive at a beginning, a singular moment when all of space and time burst forth in an immense expansion, a moment we now call the Big Bang. The expanding universe is the echo of that beginning, the continuing motion of creation itself. Every second, the fabric of space stretches a little more, carrying galaxies farther from one another, reshaping the cosmos in ways both subtle and immense. The night sky we see now is only a temporary arrangement, a fleeting picture in an ever-changing universe. To grasp the expansion, it helps to think of analogies. Imagine a balloon with tiny dots drawn on its surface. As the balloon inflates, the dots move farther apart from one another, not because they are crawling across the surface, but because the surface itself is stretching. This is how galaxies move apart in space. It is not that they are flying through the cosmos, but that the cosmos itself is expanding between them. There is no central point from which everything is moving outward. Instead, expansion happens everywhere, at once, equally, across all of space. This is one of the most challenging ideas to internalize, for we are used to thinking in terms of objects moving through a pre-existing space. But in the expanding universe, space itself is dynamic. As space expands, so too does the horizon of the unknown. The light from the most distant galaxies takes billions of years to reach us, but because the universe is expanding, those galaxies are now much farther away than they were when their light began its journey. Some galaxies are receding so quickly that their light will never reach us, lost to the relentless stretching of space. This means that there are regions of the universe we will never be able to see, no matter how advanced our technology becomes. They are simply beyond our cosmic horizon, hidden not because of distance alone, but because the very fabric of the universe denies us access to them. This expansion is not uniform in its history. In the earliest moments of the cosmos, a fraction of a second after the Big Bang, the universe underwent a period of rapid inflation, swelling at speeds faster than light itself. This inflation stretched quantum fluctuations into vast cosmic structures, seeding the galaxies and clusters we observe today. After this, the expansion slowed, governed by the pull of gravity as matter coalesced into stars and galaxies. But billions of years later, something unexpected occurred. Instead of slowing down as scientists predicted, the expansion began to accelerate. This startling revelation, confirmed in the late 1990s by observations of distant supernova, pointed to the presence of a mysterious force, dark energy pushing the universe outward. The expansion, once thought to be a gentle slowing, had become an unstoppable speeding. This acceleration changes how we think about the universe's future. If expansion continues at its current rate, distant galaxies will drift farther and farther away until they disappear entirely from view, their light stretched into invisibility. One day, countless billions of years from now, the sky may appear empty, stripped of stars beyond our own galaxy. Future observers, should any exist, might look into the heavens and see only darkness, unaware of the vast cosmos that once lay beyond. The expanding universe is not just a story about the past, but also about the destiny of everything we know. But what does this mean for the idea of the other side of the universe? If the cosmos is expanding, then the other side is not fixed, not waiting at some distant wall, but always receding, always shifting farther into the unreachable. To chase it is like chasing the horizon. No matter how far you travel, it retreats ahead of you. The more the universe expands, the larger the unknown becomes. The other side, in this sense, is not a destination we can arrive at, but a mystery that grows as we learn more. The universe expands, and with it, the boundaries of our curiosity. There is also a deeper implication in this expansion. If the universe is truly infinite, then the concept of sides may not apply at all. An infinite cosmos has no edge, no beyond, no boundary. Expansion does not create more space in the sense of new territory appearing. Instead, It stretches the existing fabric infinitely in every direction. But if the universe is finite, curved back upon itself like the surface of a sphere, then traveling far enough might bring us back to our starting point. In such a universe, there is no other side, because every point is part of the same continuous whole. The expanding universe does not solve these questions, it deepens them, reminding us that reality may be far stranger than we imagine. For us here on Earth, the expansion of the universe is not something we feel in our daily lives. Galaxies move apart, but the atoms in our bodies, the Earth beneath our feet, and the solar system we call home are bound together by forces far stronger than cosmic expansion. Gravity, electromagnetism, the bonds of matter itself, these hold us together, resisting the pull of space's stretching fabric. Yet even as we remain unaware of it in our immediate surroundings, the expansion shapes everything on the largest scales, dictating the past, present, and future of the cosmos. To lie beneath the stars and think of the expanding universe is to surrender to a sense of vastness. It is to imagine every galaxy, every star, every wisp of cosmic dust carried outward in an endless motion, like leaves floating on an invisible current. It is to know that the universe we see is only a temporary image, destined to change, to fade, to stretch into something unrecognizable. And it is to realize that the question of what lies on the other side of the universe is inseparable from the question of expansion itself. The other side is always moving, always beyond, always part of a universe that is not still but forever in motion. When we stand beneath the night sky and gaze into the vastness of space, it feels as though our vision extends endlessly. We imagine that with the right telescope, we could peer farther and farther until the entire universe is revealed to us. Yet, in truth, there is a limit to what we can see, a boundary, not made of walls or edges, but defined by the very nature of light and time. This boundary is called the cosmic horizon, and it is one of the most profound concepts in cosmology. It marks the edge of the observable universe, the farthest distance from which light has had time to reach us since the beginning of cosmic history. Beyond that horizon, there is more universe, but it lies hidden from view, veiled forever by the finite speed of light and the ongoing expansion of space. To speak of the cosmic horizon is to confront the idea that the universe is vastly greater than we will ever directly witness, and that the other side of reality may remain perpetually out of reach. The idea of a horizon is familiar to us here on Earth. When you stand at the shore and look out to sea, your vision is limited by the curvature of the planet. Ships appear from beyond the horizon, emerging gradually into view, and then vanish as they sail away. But the horizon on Earth is an illusion of perspective. With the right vantage point, say from a mountaintop or an airplane, you can extend it farther. The cosmic horizon, however, is different. It is not an obstacle we can climb above or a curtain we can pull aside. It is a fundamental limit set by the laws of physics. No matter how powerful our instruments become, no matter how advanced our technology grows, we cannot see beyond it. The light from beyond the cosmic horizon has not had enough time to reach us, and in some cases, it never will. To understand this horizon, we must return to the beginning of the universe. About 13.8 billion years ago, in the moment we call the Big Bang, space and time themselves came into existence. From that instant, light began to travel outward, carrying information across the newborn cosmos. But because the universe has a finite age, there is only so much light that could have reached us since that time. The cosmic horizon is defined by this limit, the maximum distance light has been able to travel in the lifetime of the universe. It is, in essence, a sphere around us, centered on Earth, with a radius of about 46 billion light years. Everything inside that sphere is part of our observable universe. Everything beyond it exists, but it is invisible, unreachable, locked away behind a veil of time and distance. The number 46 billion light years may sound paradoxical. After all, the universe is 13.8 billion years old. So how can we see objects farther away than 13.8 billion light years? The answer lies in the expansion of space. While the light was traveling toward us, the universe itself was stretching, increasing the distance between us and the source of that light. As a result, the objects we observe at the edge of visibility are now far more distant than they were when their light began its journey. They lie 46 billion light-years away today, even though their light has been traveling for less than 14 billion years. This is the strange geometry of an expanding cosmos, and it is one of the reasons why the cosmic horizon is so much larger than intuition might suggest. When we look toward this horizon, what we see is not stars or galaxies in the usual sense. At the very edge of visibility lies the cosmic microwave background, a faint afterglow left over from the early universe. This light was released about 380,000 years after the Big Bang, when the universe cooled enough for atoms to form and photons to travel freely. Before that time, the cosmos was a hot, opaque fog of particles, impenetrable to light. The microwave background is the oldest light we can see, the farthest we can peer into the past. Beyond that, the universe is hidden, because it does not exist, but because light itself cannot carry the story to us. The cosmic horizon thus becomes not only a boundary of space, but also a boundary of time. The existence of a horizon forces us to confront a humbling reality. Most of the universe is beyond our reach. If the cosmos is infinite, then what we see is only an infinitesimal fraction of its entirety. Even if it is finite but vast, we will never perceive it in full. Our observable universe is a bubble of knowledge floating in a larger ocean of the unknown. The galaxies we see, the clusters and superclusters we map, are but a local neighborhood compared to the totality that exists beyond the horizon. And because of cosmic expansion, many of those distant realms will remain hidden forever, their light stretched into invisibility, their existence detectable only in theory. This realization also reshapes the way we think about the question, what is on the other side of the universe? From our vantage point, the other side is always beyond the horizon, forever hidden from our view. We can imagine it, speculate about it, and even build theories about what it might contain, but we cannot observe it directly. The cosmic horizon is like a cosmic shoreline, beyond which the waves of light have not yet reached. We stand on this shore, gazing into the distance, aware that there is more but unable to set sail across it. The horizon also raises questions about the nature of the universe itself. If what lies beyond is similar to what we see within, then the cosmos may be homogeneous and isotropic on the grandest scales, essentially the same everywhere. This idea, called the cosmological principle, underpins much of modern cosmology. But what if it is not the same? What if the regions beyond our horizon differ in structure, in laws, or even in fundamental properties? We cannot know for sure, and this uncertainty is one of the profound mysteries of existence. The horizon may conceal not only more galaxies, but also answers or perhaps deeper questions that we will never access. For scientists, the cosmic horizon is not only a barrier, but also a tool. By studying the light near its edge, particularly the microwave background, researchers can learn about the conditions of the early universe. The tiny fluctuations in that background radiation reveal the seeds of structure, the patterns that grew into galaxies and clusters. They tell us about the composition of the cosmos, the proportions of matter, and dark energy. In this way, the horizon becomes both a limit and a limit to what we can see, but a window into the origins of everything we know. There is also something deeply poetic about the horizon. To lie in the quiet of night and imagine a boundary. To vision is to realize that we live in a universe of mysteries, where the unknown vastly outweighs the known. It is to feel small and yet profoundly connected, a tiny consciousness aware of limits, but capable of dreaming beyond them. The cosmic horizon reminds us that our place in the universe is both central, in the sense that every observer has their own horizon, and insignificant, in the sense that we are surrounded by an immensity we can never fully grasp. Some philosophers and physicists even speculate about what horizons mean for reality itself. If we can only ever know what lies within our observable bubble, then the universe beyond might as well be a different cosmos altogether, separate in every practical sense. Perhaps there are endless regions beyond our view, each with its own stars, galaxies, and perhaps even life. Or perhaps the universe folds back on itself in ways we cannot perceive, and what lies beyond the horizon is ultimately a return to what we already know. The truth may forever elude us, hidden behind the veil of cosmic time. When we begin to ask what lies on the other side of the universe, we soon arrive at a place where observation can no longer guide us, and imagination must take the lead. The vastness of space, the limits of the cosmic horizon, and the strangeness of expansion all point toward mysteries that may never be directly visible. Yet human curiosity refuses to stop there. Instead, it ventures into ideas so bold and so sweeping that they stretch the very meaning of reality. Among these is the notion of parallel universes, the possibility that our universe is not the only one, but rather one of many, perhaps infinitely many, in what some call the multiverse. To contemplate the multiverse is to move beyond the comfort of stars and galaxies into a realm of pure wonder, where every possibility might be real, and where the other side of the universe could be not just more of the same, but an entirely different reality altogether. The idea of other universes is not new. Ancient myths and philosophies often imagine multiple worlds layered upon one another, realms of gods and spirits existing alongside our own. But in modern science, the idea emerges not from myth, but from mathematics, physics, and the strange consequences of theories about space, time, and quantum mechanics. The multiverse is not one single theory, but a family of concepts, each arising from a different line of reasoning, yet all suggesting that what we call the universe may be only a small piece of a far grander existence. One of the most compelling roots to the multiverse comes from the theory of cosmic inflation. According to this idea, in the earliest fractions of a second after the Big Bang, the universe underwent a phase of exponential expansion, stretching unimaginably fast, far faster than the speed of light. This inflation explains why the universe today appears so uniform and flat on large scales. But inflation, if it occurred, might not have stopped everywhere at once. In some regions, expansion could have ended, creating bubbles of space where matter and galaxies could form, our universe being one of these bubbles. Yet in other regions, inflation may have continued, endlessly spawning new bubbles. This picture, known as eternal inflation, suggests that our universe is one bubble in a vast froth of universes, each perhaps with its own laws of physics, its own galaxies, even its own versions of reality. If this is true, then the other side of our universe may not be an edge, but the border of a bubble, beyond which lies another bubble, and another, endlessly, forever. Another path to the multiverse comes from the strange principles of quantum mechanics. In the quantum world, particles do not exist in definite states until they are observed. Instead, they exist in probabilities, in superpositions of many possibilities. The many worlds interpretation of quantum mechanics takes this literally. Every possible outcome of a quantum event actually occurs, but in separate, branching realities. In this view, when you make a choice, reality splits, one universe containing the path you chose, another containing the path you did not. The multiverse here is not distant in space, but intertwined with our own reality, splitting and branching endlessly, so that every possibility is realized somewhere. This idea is unsettling, yet strangely beautiful, for it suggests that beyond the universe we know lies an infinity of others, each playing out variations of events, each containing other versions of ourselves. String theory, another framework of modern physics, also offers its own vision of the multiverse. In string theory, the fundamental building blocks of reality are not particles, but tiny vibrating strings, whose vibrations determine the properties of matter. But string theory also requires extra dimensions beyond the three of space and one of time we perceive. These extra dimensions could be curled up in complex ways, producing different physical laws depending on their shape. The landscape of possible universes in string theory is vast, perhaps unimaginably so, with each possible configuration of dimensions giving rise to a different universe with its own rules. If this landscape exists, then our universe is only one point upon it, chosen not by necessity, but by chance. The other side of our universe, in this sense, is not just distance, but an entire array of other realities, governed by different physics, perhaps so alien that we could scarcely imagine them. There is also the concept of the brain multiverse, arising from theories in which our universe is a three-dimensional surface, or brain, floating in a higher dimensional space. In this picture, other brains could exist parallel to ours, like sheets of paper stacked together. These other universes might be close in a higher dimension, yet forever unreachable to us. Some theorists even suggest that collisions between brains could have caused events like the Big Bang itself, sparking the creation of universes as bubbles of higher dimensional interaction. If this is true, then the other side of our universe might not be emptiness at all, but other worlds brushing against ours, and seen yet profoundly influential. These theories may sound like science fiction, and in many ways, they do stretch the limits of what science can test. Yet they are not born purely from imagination. They arise from the mathematics of our best theories, from attempts to explain the mysteries we observe, the accelerating expansion of the universe, the fine-tuned constants of nature, the strange behavior of quantum mechanics. All of these hint at deeper layers of reality. The multiverse is not proven, but it offers one possible explanation, a way to make sense of why our universe is the way it is. To think about parallel universes is to entertain possibilities that are almost impossible to fully comprehend. Imagine, for a moment, another universe where stars never formed, where the constants of physics are just slightly different, preventing galaxies from taking shape. Or another universe where time flows differently, or where dimensions fold in unfamiliar ways. Imagine a universe where life took a different path, where beings unlike anything we know evolve beneath alien suns. Or imagine a universe nearly identical to ours, with only the smallest differences, perhaps a version of Earth where history unfolded along a slightly different course. In an infinite multiverse, all of these could exist. The other side of our universe, in this grander vision, is not just a place we cannot see, but an infinity of places, each with its own wonders, its own stories, its own skies. Of course, there are critics of the multiverse concept. Some argue that because other universes are unobservable, the idea cannot be tested, and therefore falls outside the bounds of science. Others warn that the multiverse may be an unnecessary complication, a way of multiplying worlds when one should suffice. These criticisms remind us that the multiverse is not a certainty but a hypothesis, a possibility among many. And yet, the allure of the idea remains. For even if we never prove it, the thought of parallel universes expands our imagination, inviting us to consider that reality is far larger and more diverse than we can ever witness. The multiverse also invites reflection on our own existence. If countless universes exist, each with different properties, then why does ours allow for life, for galaxies, for consciousness? This is the puzzle of fine-tuning. The physical constants of our universe seem perfectly balanced to allow complexity to emerge. In the multiverse, this puzzle dissolves. Out of countless universes, some will be lifeless, others will be chaotic. And a few, like ours, will have the right conditions for life. We live in one of the rare universes where observers can exist, not because of design or necessity, but because only in such universes could beings like us ask the question at all. For the dreamer lying awake beneath the stars, the multiverse offers a different kind of comfort. It whispers that the unknown is far larger than the known, that our universe is not the entirety of existence, but one verse in a far greater symphony. It invites us to let go of the idea of limits, to imagine that every possibility has a home somewhere in the vastness of reality. The other side of the universe, in this vision, is not a single frontier, but countless horizons, each leading to a different world, each beyond our reach yet alive in the imagination. When we think of the universe, it is natural to imagine a vast expanse filled with galaxies, stars, planets, and dark space between them. Yet this picture, immense as it seems, does not capture the full depth of what science has uncovered about the cosmos. At the very foundation of our understanding of the universe lies the concept of cosmic inflation, an idea that pushes us to consider realities so immense that they stretch far beyond ordinary comprehension. Cosmic inflation is not just a theory about the early moments of existence, but also a window into the possibility of infinity itself. To ask what lies on the other side of the universe is to wrestle with the possibility that there may be no other side at all, only an endless continuum with no edge, no boundary, and no end. The story of inflation begins at the very dawn of time. The Big Bang, as it is commonly described, marks the moment when the universe as we know it came into being. Space and time, matter and energy, all emerged in an instant of unimaginable density and heat. But if the Big Bang alone were the whole story, the universe we see today would not make sense. Observations reveal that on the largest scales, the universe is astonishingly smooth and uniform. No matter where we look, galaxies are spread evenly, and the cosmic microwave background radiation is nearly the same temperature in all directions. Without inflation, this uniformity would be inexplicable, because distant regions of the universe are too far apart to have ever interacted or shared information. Inflation solves this puzzle by proposing that in the tiniest fraction of a second after the Big Bang, the universe underwent a period of exponential expansion, ballooning outward at speeds far faster than light itself. During this brief, but extraordinary phase, the universe grew from smaller than a subatomic particle to something vast enough to encompass everything we observe today. In less than a trillionth of a second, the cosmos expanded unimaginably, flattening itself, smoothing out irregularities, and setting the stage for galaxies and stars to form billions of years later. Inflation explains why the universe looks the way it does, why it is flat instead of curved, why it is so uniform, and yet also why there are tiny fluctuations that seeded the structure we see now. Without it, the universe as we know it could not exist in its present form, but inflation carries with it implications that go far beyond these explanations. If space can expand at such a rate, if the fabric of reality itself can stretch faster than light, then the universe may be far larger than the portion we can observe. The cosmic horizon, vast as it seems, may only reveal a minuscule part of the whole. Beyond what we can see, the universe could extend forever, stretching into infinity. Inflation suggests that there is no outer wall, no end where the universe simply stops. Instead, it might continue endlessly in every direction, larger than any map could capture, greater than any thought can fully encompass, and inflation may not have been a one-time event. Some versions of the theory suggest that inflation is eternal, continuing indefinitely in parts of the cosmos. In this view, while inflation ended in our region, allowing galaxies and stars to form, it may still be occurring elsewhere, endlessly, spawning new regions of space. Each of these regions, sometimes called pocket universes or bubble universes, could be disconnected from our own, unreachable and separate, yet all part of a grander multiverse. If eternal inflation is real, then what we call the universe is just one bubble in an infinite froth of creation, one pocket among countless others. Each bubble could contain its own physical laws, its own arrangement of galaxies, perhaps even its own versions of time and space. The other side of our universe, in this sense, is not a boundary, but another universe altogether, existing in parallel but forever apart. The concept of infinity is difficult for the human mind to truly grasp. We are used to things having limits, beginnings, and ends. A road stretches to the horizon, but eventually it stops. A life begins with birth and ends with death. Even the oceans, vast and seemingly endless, have shores that define them. But infinity has no shore. To imagine an infinite universe is to accept that no matter how far you travel, there will always be more. Every direction stretches on without end. There is no center, no edge, no final frontier. Infinity is not just a large number, it is beyond numbers, a concept that defies the very idea of counting or measuring. To imagine the universe as infinite is to imagine existence itself as without boundary, without a frame, a vastness that cannot be contained. Cosmic inflation pushes us toward this vision. By explaining how the universe could become so vast and uniform in such a short time, it also opens the door to the idea that what we see is only a fragment of an endless whole. And if the universe is infinite, then the implications are staggering. In an infinite cosmos, every possible configuration of matter could exist somewhere. There could be another Earth, far beyond our horizon, identical in every detail, where another version of you sits, asking the same questions. There could be countless variations, some nearly the same, others utterly different, all existing somewhere in the boundless expanse. Infinity means that possibility itself is realized endlessly, without limit, yet infinity is not just a mathematical abstraction. It carries with it a profound sense of mystery and awe. To stand beneath the stars and consider infinity is to feel the limits of human imagination. No matter how far we think, we cannot reach the end, because there is no end to reach. Inflation does not merely describe the birth of the cosmos, it points us toward a reality that is forever larger than ourselves, forever beyond comprehension. The infinite universe is not something we can contain in thought, but something we can approach only with wonder, humility, and a sense of peace. For some, the idea of infinity is unsettling. If the universe has no boundaries, then where do we belong within it? If there are infinite versions of reality, then what does it mean to be unique, to live a single life in a single world? These questions remind us that infinity challenges not only science, but also philosophy, identity, and meaning itself. Yet for others, infinity offers comfort. In an endless universe, nothing is truly isolated, nothing is truly final. Every possibility is realized, every story has its place, every life is part of an unending tapestry that stretches beyond the horizon. Cosmic inflation, with its suggestion of infinity, also reshapes how we think about the future. If the universe is infinite, then its story has no conclusion. Galaxies may drift apart, stars may fade, and the cosmos may grow cold and dark. But somewhere other regions, new galaxies may still be forming, new stars still igniting, new worlds still emerging. Creation itself never ceases, for infinity has no final chapter. The universe is not a closed book, but an endless library, each page leading to another, each story flowing into countless others. In the quiet of night, when the world is still, and the stars shine faintly above. To think of cosmic inflation and the infinite is to drift into a sense of boundlessness. It is to let go of the need for edges and embrace the possibility of endlessness. It is to realize that what lies on the other side of the universe may not be a wall or an end, but more universe, stretching forever, larger than time, larger than thought, larger than any dream we could hold. When we look at the universe, we see galaxies drifting apart, stars shining across unimaginable distances, and the faint glow of the cosmic microwave background, a whisper from the beginning of time. But beneath all of this visible grandeur lies something unseen, something mysterious that makes up most of the cosmos, and yet cannot be touched or directly observed. This hidden presence is called dark energy, and it is perhaps the most enigmatic force in all of physics. It is the silent driver of the universe's expansion, the invisible hand shaping the future of everything that exists. To ask what lies on the other side of the universe is to also ask about dark energy, for it is the strange force that decides how the cosmos stretches, how it evolves, and ultimately, what its destiny will be. The story of dark energy begins in the late 1990s, when astronomers studying distant supernova made a discovery that shook the foundations of cosmology. They expected to find that the expansion of the universe was slowing down, gradually being pulled back by the gravity of all the matter it contained. Instead, they found the opposite. The universe was not slowing, it was accelerating. Galaxies were flying away from each other faster and faster, as though some hidden force were pushing them apart. This was astonishing, because nothing in known physics could explain such a phenomenon. To account for it, scientists gave it a name: dark energy. Dark energy is not like the energy we encounter in daily life. It is not the energy of motion, or heat, or electricity. It is not bound up in matter or radiation. Instead, it seems to be a property of space itself, an energy woven into the very fabric of the cosmos. As the universe expands, more space comes into existence, and with it, more dark energy. This is what drives the acceleration, an ever-present pressure that pushes galaxies apart. Though invisible and undetectable except through its effects, dark energy dominates the cosmos. Today, it makes up roughly 70% of the total energy content of the universe, while dark matter contributes about 25%, and ordinary matter, the atoms that make stars, planets, and people, accounts for less than 5%. The universe we see is only a tiny fraction of what truly exists, a small island of the known floating in an ocean of the unknown. The nature of dark energy remains one of the deepest mysteries in science. Some physicists think it may be the cosmological constant, an idea first introduced by Albert Einstein. In his equations of general relativity, Einstein added a constant to allow for a static universe, but later abandoned it when evidence showed the cosmos was expanding. Now, with the discovery of acceleration, his idea has returned, suggesting that space itself may have a built-in energy that resists collapse. Others propose that dark energy is not constant but dynamic, changing over time, perhaps tied to a new kind of field that permeates the cosmos. Still others imagine that what we call dark energy may be a sign that our theories of gravity are incomplete, that the laws we know are only approximations of a deeper reality. Each of these possibilities points toward a profound mystery, a reminder that the universe holds secrets far beyond our present grasp. Dark energy is not only a puzzle of the present, it is also the key to the future. How it behaves will determine the ultimate fate of the cosmos. If dark energy is constant, continuing to push space apart forever, then galaxies will drift farther and farther from one another, until they disappear from view entirely. Billions of years from now, the night sky may grow empty, stripped of all but the nearest stars, as the expansion carries everything else beyond the cosmic horizon. Stars will burn out, galaxies will fade, and the universe will grow cold and dark in what scientists call the heat death, a silent, eternal expansion into nothingness. But if dark energy grows stronger over time, its effects could be even more dramatic. Some theories suggest a scenario known as the Big Rip, in which the accelerating expansion becomes so powerful that it eventually overcomes all other forces. Galaxies would be torn apart, stars scattered, planets ripped from their orbits, and even atoms themselves pulled apart. In such a fate, the universe would end not in silence, but in a catastrophic tearing of space and matter, leaving nothing behind but a thin, diffuse void. On the other hand, if dark energy is not constant, but decays or changes in sign, the expansion could slow down, stop, or even reverse. In that case, gravity would eventually pull everything back together, leading to a big crunch, where galaxies collapse inward, stars fall into black holes, and all matter converges once more into a singular state of heat and density. The universe could then end in fire as it began, or perhaps bounce into a new cycle, expanding again after collapse in an endless rhythm of birth, death, and rebirth. Each of these possibilities, heat death, big rip, big crunch, depends on the nature of dark energy, a nature we do not yet fully understand. In this way, dark energy acts as a kind of cosmic storyteller, determining not only the current shape of the universe, but also its final chapter. And yet, because we cannot directly see or touch it, we are left with only hints and guesses, measurements and models. The mystery of dark energy is both humbling and inspiring. It reminds us that even after centuries of study, the cosmos still keeps its deepest truths hidden, offering only glimpses of its greater reality. But even in its mystery, dark energy inspires a kind of quiet wonder. Imagine galaxies drifting endlessly into the distance, carried by the expansion of space itself. Imagine the vast silence of a universe where light itself is stretched into invisibility, where the stars fade one by one until only darkness remains. Imagine, too, the possibility of cycles, of universes reborn, of existence unfolding not once, but infinitely, guided by forces we barely comprehend. Dark energy is not just a scientific puzzle, it is a meditation on impermanence, on the vast scales of time and space that dwarf our lives and yet invite us to dream. In daily life, the presence of dark energy is invisible, unfelt, and yet it shapes the very framework in which we exist. It stretches the space between galaxies while leaving the atoms of our bodies untouched. It expands the cosmos while our world continues in its familiar rhythms. Its influence is so vast, so gentle and constant, that we do not notice it, yet, without it, the universe would not be what it is. To reflect on dark energy is to realize that we are carried along on a tide we cannot feel, borne forward by a current that shapes the destiny of all things. When we ask about the other side of the universe, dark energy gives us an answer that is both strange and profound. The other side is not fixed, but ever moving, carried outward by the accelerating expansion. It is always farther than we can reach, always beyond the horizon, forever slipping away as space itself stretches. The universe is not static but alive, with motion, its destiny written in the invisible hand of dark energy. To lie quietly beneath the stars and think of this force is to drift into a sense of vastness, to feel the pull of the unknown, and to recognize that the universe is not only larger than we imagine, but larger than we can imagine. When we look into the night sky, we see the familiar sight of stars, the pale glow of the Milky Way, and perhaps the distant swirl of a galaxy through a telescope. These are the realms of the observable universe, the places we can measure and map with light that has traveled across space for billions of years to reach us. Yet the question of what lies beyond is not answered by observation alone. Science, imagination, and philosophy invite us to consider whether there may be other realms, hidden realities that exist alongside or beyond our own. These other realms could take many forms: higher dimensions, parallel universes, or even unseen structures in the very fabric of reality. While our senses reveal only the surface of existence, the possibility of other realms suggests that the universe may be far deeper, stranger, and richer than we can directly perceive. The idea of hidden realms is not new. For centuries, humans have imagined worlds beyond their own, from ancient myths of heavens and underworlds to early philosophical speculations about infinite space. But with the rise of modern science, these imaginings have been reshaped into theories grounded in mathematics, physics, and cosmology. One of the most compelling frameworks for hidden realms comes from the concept of higher dimensions. We live in a universe of 3 dimensions of space and 1 of time, and yet many physical theories, including string theory, suggest that there could be more. These extra dimensions might be curled up, invisible to us, existing at scales too small to detect. If true, our universe is not the full story, but only the part we can experience, like the surface of an ocean that hides unfathomable depths beneath. Higher dimensions, if they exist, might allow for realities we cannot easily imagine. In our 3-dimensional world, we can move forward and backward, left and right, up and down. A being of higher dimensions could move in directions we cannot conceive, perceiving our entire universe as a thin slice within a larger whole. To such a being, what seems vast and endless to us might appear small and limited, much like a flat drawing looks simple to someone who lives in 3 dimensions. The possibility of higher dimensions suggests that what we call the universe may be only part of a greater structure, a realm within realms, where existence unfolds in ways beyond our grasp. Another possibility of other realms comes from the idea of parallel universes. As we explored in the concept of cosmic inflation, the universe may not be a single, isolated bubble, but part of a grander multiverse. If inflation is eternal, then countless other regions of space may exist beyond our own, each with its own laws of physics, its own galaxies, its own histories. Some might be similar to ours, others utterly alien, filled with forms of matter and energy we cannot imagine. To think of these realms is to consider that reality is not singular, but plural, a vast tapestry of universes without end. Our universe may be but one thread in a cosmic fabric woven with infinite variations. These parallel universes may never touch our own, separated by vast expanses of inflating space, but some theories suggest connections are possible. Wormholes, theoretical tunnels through space and time, might link different regions of the universe, or even different universes altogether. If such structures exist, they would be like bridges across realms, shortcuts through dimensions that defy ordinary travel. Though purely speculative at present, wormholes capture the imagination because they hint at the possibility of moving beyond the limits of our universe, of touching the unknown directly. To imagine entering a wormhole is to imagine stepping into another realm, leaving behind the familiar stars and galaxies to emerge into a reality that might be unrecognizable. The possibility of other realms also arises from quantum mechanics, the strange and counterintuitive theory that governs the smallest scales of existence. In the quantum world, particles do not exist in definite states until observed, but rather in probabilities, superpositions of many possibilities at once. One interpretation of this behavior is the many worlds theory, which suggests that all possible outcomes of quantum events actually occur in its own branch of reality. If this is true, then every choice, every event, every moment splits into countless versions, creating an infinite branching of universes. In one realm, you took a different path, made a different decision, a different life. In another, whole worlds evolved differently, shaped by quantum outcomes that diverged long ago. These realms would not be beyond the horizon of space, but existing alongside us, invisible and unreachable, yet as real as our own. To think of other realms is to stretch the mind into directions that can be both exhilarating and humbling. These realms might not resemble anything we know. Some may lack matter as we understand it. Others may lack time in the way we experience it. Some may have physical laws so different that stars, planets, and life are impossible, while others may teem with forms of existence beyond imagination. The vastness of possibility is a reminder that our universe, familiar and beautiful as it is, may not be the only way reality can be structured. What we see may be but one example, one expression, of a deeper, infinite creativity woven into the fabric of being. The thought of other realms also changes how we think about the universe itself. If other realms exist, then the universe is not a closed system, but part of something larger. Our cosmos, vast as it seems, may be like a single island in an archipelago of realities. Just as ancient explorers once wondered what lay beyond the horizon of their seas, so too do we now wonder what lies beyond the horizon of our universe. And just as those explorers eventually found new lands and new worlds, so too may future generations find evidence of other realms, hints that reality is richer than we ever imagined. The possibility of other realms also raises profound questions about our place in existence. If there are countless universes, what does it mean to live in this one? If there are infinite variations of reality, what does it mean to be unique? These questions do not diminish the value of life, but enrich it, reminding us that existence itself is a miracle, one expression among countless others, each as real and meaningful as the next. To think of other realms is to realize that our story is part of a far greater narrative, a cosmic tale unfolding across dimensions and universes, without end. At the same time, the mystery of other realms is a gentle reminder of humility. We may never be able to prove their existence, never step into them, never observe them directly. They may remain forever hidden, known only through the language of mathematics and imagination. Yet the very act of considering them expands our sense of wonder. It pushes us to dream bigger, to ask deeper questions, to recognize that the universe is not just what we see, but also what we cannot yet see. In this way, Other realms serve not only as scientific speculation, but also as a meditation on the infinite, a way of embracing the unknown as a source of beauty rather than fear. When we think of other realms, we might imagine them as places beyond the stars, hidden behind the veil of space and time. But perhaps they are not far away at all. Perhaps they exist alongside us, interwoven with our own universe, and seen yet present, like hidden notes in a song we cannot hear, but that still resonate in the fabric of reality. To consider this possibility is to realize that the cosmos may be layered, textured, filled with dimensions and universes that lie just beyond our senses. What lies on the other side of the universe may not be emptiness but richness, a multiplicity of realms where the story of existence unfolds in ways we cannot yet know. Since the first humans looked up at the night sky, curiosity has been woven into the fabric of our being. We are creatures who do not simply live within the universe. We question it, we search its depths with our minds, and we ask over and over again, what lies beyond? This desire to understand is one of the most defining traits of humanity. While animals navigate their worlds with instinct and survival, humans carry within them an endless thirst to know why things are the way they are, how they came to be, and where they might lead. This is the human quest for answers, and when it comes to the question of what lies on the other side of the universe, this quest becomes both profound and poetic. Our search begins with wonder. Long before telescopes, before science as we know it, people gazed at the stars and built stories to explain them. Myths of gods, heavens, and hidden worlds were humanity's first attempts to reach beyond the visible. These stories were not mistakes, but expressions of the same impulse that drives science today, the need to make sense of the cosmos. Ancient observers mapped the motions of the planets, tracked the cycles of the moon, and used the stars to navigate across seas. Each observation was a step in a journey, a torch that lit the way forward. What we now call astronomy grew from this primal wonder, a testament to our refusal to let the unknown remain in silence. As centuries passed, our methods grew sharper, our tools more powerful. Galileo's telescope opened the heavens to direct human sight, revealing mountains on the moon, moons around Jupiter, and the countless stars hidden within the Milky Way. Newton's laws showed that the same force that pulls an apple to the ground guides the planets in their orbits. Einstein's theories of relativity revealed the strange, curved nature of space and time. And more recently, modern cosmology has shown us that the universe is expanding, that it began in a fiery birth nearly 14 billion years ago, and that it is filled with mysteries like dark matter and dark energy. Each of these discoveries was not an end but a door, opening to deeper questions, drawing us ever onward in our quest. Yet for all the answers we have found, the greatest truths still elude us. We know the universe is expanding, but we do not fully know why. We can describe the beginning of the cosmos, but not what came before it. We can measure the structure of galaxies, but not the full nature of the forces that shape them. It is this mixture of knowledge and mystery that defines the human quest for answers. We live in a tension between what we know and what we long to know, between the light of understanding and the shadow of the unknown. And in this tension, something beautiful emerges. The mystery itself becomes part of the answer. The unknown reminds us that the universe is not exhausted by our explanations, that there is always more to discover, more to imagine, more to explore. What lies on the other side of the universe is the ultimate version of this mystery. It is a question that may never be answered fully, for the cosmic horizon is a limit built into the nature of space and time. No matter how powerful our telescopes become, there will always be regions beyond our reach, places too far for light to ever arrive. And yet, the human spirit refuses to accept the horizon as an end. We imagine, we theorize, we build models of inflation, multiverses, higher dimensions, and other realms. We allow our curiosity to leap beyond what we can see, crafting visions of the infinite not because we can confirm them, but because our minds cannot help but seek them. The act of asking is as important as the act of answering, for the questions themselves give meaning to our journey. This quest is not only scientific, but deeply personal. Each individual who gazes at the stars and wonders about the other side of the universe participates in a story as old as humanity itself. When you lie awake at night and let your thoughts drift to the cosmos, you are joining a lineage of seekers who have carried these same questions through countless generations. From ancient storytellers to modern scientists, from children making wishes on stars to astronauts gazing down at Earth from orbit, all are part of the same search. The quest for answers unites us, transcending time, culture, and place, binding us together in a shared wonder that is larger than any one life. In the quiet moments, this quest also teaches us humility, to realize that the universe is vast beyond imagination, to accept that there may be realms we can never reach, is to confront the limits of human power. We are small, fragile beings living on a tiny planet circling an ordinary star, in a galaxy that is but one among billions. And yet, within that smallness lies something extraordinary. We are aware of it. The universe may be vast, but it is through us that it becomes known, through our questions that it becomes illuminated, through our curiosity that it is given voice. The quest for answers may not grant us mastery over the cosmos, but it grants us meaning, reminding us that to seek is itself a kind of triumph. The search for what lies beyond also reveals the resilience of the human mind. We continue to ask questions even when answers seem impossible. We continue to build theories even when proof is beyond our reach. We continue to dream of traveling among the stars, of sending ships to other galaxies, of peering beyond the cosmic horizon, even though such feats may take lifetimes or may never be realized at all. The quest is not deterred by impossibility, it is fueled by it. Each limit we encounter becomes a challenge, each mystery an invitation, each unknown a horizon to pursue. In this way, the human spirit is infinite, mirroring the vastness of the universe itself. The quest for answers is also deeply tied to our sense of identity. To ask what lies beyond is to ask who we are within the cosmos. Are we alone, or are there other beings in distant realms asking the same questions? Are we a fleeting moment in an endless cycle, or a unique expression of the universe's unfolding story? These questions are not only scientific but philosophical, shaping how we see ourselves and our place in existence. To search for answers is to search for meaning, to weave our lives into the larger fabric of reality, to recognize that our small stories are part of a grand cosmic narrative. In the end, the human quest for answers is not only about what we discover, but about what we become in the act of seeking. Each step in our journey transforms us, expanding our minds, deepening our wonder, and reminding us that the universe is not just out there, but also within us. The atoms in our bodies were forged in stars. The energy that fuels us was born in the Big Bang. The consciousness that asks these questions is itself a part of the cosmos, reflecting on its own nature. When we ask what lies on the other side of the universe, we are not just asking about distant galaxies or hidden realms. We are asking about ourselves, about the infinite capacity of the human mind to wonder, to imagine, and to seek. As we bring this journey to a close, let us return to the simple act that began it all, looking up at the night sky and wondering what lies beyond. We have drifted together through vast mysteries, exploring the great unknown beyond the stars, the expanding universe that stretches outward without end, the cosmic horizon that marks the limits of what we can see, the speculation of parallel universes and infinite realities, the early moments of cosmic inflation and the possibility of endlessness, the unseen force of dark energy guiding the fate of all things, the hidden possibility of other realms layered within existence, and finally, the unshakable human quest for answers, which carries us ever forward. The universe has revealed to us fragments of its story, yet it keeps its deepest secrets veiled, reminding us that wonder is not diminished by mystery, but enriched by it. To ponder what lies on the other side of the universe is to recognize both the enormity of creation and the quiet significance of our own small lives within it. We are seekers in a cosmos without edges, travelers in thought if not in space, reaching outward with curiosity even as we drift inward toward sleep. And so, as the vastness of the universe stretches silently beyond the horizon of our sight, we find comfort in knowing that the search itself is part of the answer. The act of asking, the act of wondering, the act of imagining, all connect us to something larger than ourselves. The other side of the universe may forever remain beyond our grasp, but in seeking it, we find meaning, perspective, and peace. The stars may lie far away, but the wonder they inspire lives here, within us, glowing as quietly and as endlessly as the light of the cosmos itself.